Now we talk about the missionaries and cannibals problem. This is one example of the classic river crossing puzzles which can be solved using AI algorithms. So there are three missionaries marked as M and three cannibals marked with capital C wish to cross the river. They have a small boat that will carry up to 2 people. Everyone can navigate the boat. That means both a missionary and a cannibal can ride the boat or take it to the other side. If at any time the cannibals outnumber the missionaries on either bank of the river, they will eat the missionaries. That means if there is one missionary and two cannibal, or two missionary and three cannibal, so the missionaries will be eaten by the cannibals. So we need to find the smallest number of crossings that will allow everyone to cross the river safely. Please understand, one boat to cross the river from left to right bank or vice versa. A boat can take only 2 persons at a time, and everyone can navigate the boat. And the constraint is that if cannibals are more than missionaries, missionaries will be eaten. And how we cross the river, all of them with smallest number of crossings. So similar problems are the farmer taking their goat and cabbage and a fox and crossing the river. Similar other river crossing puzzles are there. So this is a classic example. So now we want to kind of model or identify the problem, different aspects of the problem. So the states are the combination of missionaries and cannibals and boat on each side of the river. Okay, so like 3 missionaries, 2 cannibals, and the boat on the left bank. So this combines a state. Initial state is 3 missionaries, 3 cannibals, and the boat are on the near bank, near to the missionaries and the cannibals. So the successor function will move boat containing some set of occupants across the river in either direction to the other side. The constraint is missionaries can never be outnumbered by cannibals on either side of the river, or else the missionaries are killed. Okay? So constraint is missionaries can never be outnumbered by the cannibals, remember. And the action is ride the boat with maximum 2 persons, 1 or 2, across the river in either direction to the other side. So the goal test will check whether we moved all missionaries and cannibals across the river or not. The path cost will require minimum number of moves. Okay, so there is for this problem we will show that how it can be solved. Now, how to solve the problem? Before that, we want to show the missionaries and cannibal state space and want you to solve it or explore it by yourself. So this is an example where 3, 3, 1 means there are 3 missionaries, 3 cannibals, and the boat is on the left bank, let's say 1. 3, 3, 1. Now the boat needs to cross the river and go to the other bank, which will be marked with 0. So when the boat goes to the other side, what are the possibilities? The possibilities are 1 missionary and 1 cannibal goes to the other side in the boat. Just 1 missionary goes. Just 1 cannibal goes. 2 missionaries goes to the other side. 2 cannibals go to the other side. These are the 5 possibilities. So this one means 1 missionary and 1 cannibal goes to the other side, which is marked by 0. 2 cannibals go to the other side. So 3 missionaries and 1 cannibal remains on the left, and the boat is on the right side. This is the meaning. 1 missionary remains, 3 cannibals remain. So 2 missionaries have traveled to the other side. which is marked with gray, that means this is an invalid state. This is directly conflicting with the constraint because the 3 cannibals will eat the 1 missionary. They are outnumbered. Missionary is outnumbered. This one says 3 missionaries and 2 cannibals are on this side, so only 1 cannibal crossed the river. And this one means that 1 missionary has crossed the river. So this is just 1 missionary crossed the river. This is just 1 cannibal crossed the river. This says 2 missionaries crossed the river. This says 2 cannibals crossed the river. And the last or the top state here means 1 missionary and 1 cannibal crossed the river. And in that way, every step we will have some valid states and invalid states, and try to understand the states from this problem. And so you see then let me explain this state where we show that 3, 3, 1, that means 1, the missionary who went from the state from the left bank to the right bank had to drive the boat back to the left bank because the boat cannot come by itself. So again it becomes 3, 3, 1, which is nothing but the starting state. So we did not expand this, because if we expand this again we will have this 5 states. This is already visited, so we did not expand this. But this state, which is 2, 2, 0, that means 1 missionary and 1 cannibal goes to the other side. What will happen? 1 cannibal can come back taking the boat, or 1 missionary can come back taking the boat. And then we have the other possibilities from here. If we continue with all the valid possibilities, which are kind of marked with deep blue lines or thick blue lines, we will see that we will finally reach to the solution, which is 0, 0, 0, means on the left bank 0 number of missionaries, 0 number of cannibals, and the boat is on the right bank. So that means the goal state. So this is and then over that we can apply an uninformed search algorithm to see which is the best path. Thank you.